This is a brief account of the data and programming underlying the ivyGlimpse app. I want to cover installation, the basic underlying data structure, how to run the app from R, and then how to deploy such an app to the world using shinyapps.io. It's going to be extremely brief, but I want to make sure that the basic facts are known. You can install the package that contains the data and the software using DevTools install GitHub. You'll need R 3.4 probably for all this to work well, and this function should resolve all the dependencies that are needed. You may need to also acquire the summarized experiment package from Bioconductor independently. I'm not sure. Once you've got it installed, you can attach the package using library ivyGap SE, and then get the data structure that manages particularly the expression data, but also the numerical quantification of the images with data function with argument ivySE. And the value of this ivySE variable is a summarized experiment, and that is an instance of this schematic here, which is in this Nature Methods paper. It's published a couple of years ago. We're always going to be working with numerical data in a table, and that's called the assay data. And there are, in this case, 25,000 some odd features that have been assayed using RNA-seq on 270 samples. So that table is available. We can add metadata about the features, for example, mappings from gene symbols to gene identifiers in other systems, and other aspects of the features, for example, their genomic locations, in this thing called the row data. And we can also have information about each one of the samples as rows of the col data component of the summarized experiment. We also have something called metadata. This is probably obsolete by now, but the metadata component can maintain tables or other types of documents about the experiment giving rise to these assays. So that's what we have here with 25,000 genes and 270 samples. The col data actually has 28 variables, which includes information about the BAM files that give rise to the FPKMs that have been recorded as the assay results. And the col data gives you information about the samples, the block identifiers, for example, the RNA wells, and so on. Additional metadata are available, for example, in the tumor details, head of metadata, ivySE, tumor details, gives you a piece of that table showing that that's where the survival data have been recorded, for example, in addition to other molecular subtype information. The subblock information is probably the highest resolution here, so metadata of ivySE tumor subblock details. There are 946 subblocks, and that's where the image-related quantifications are made available. The app is called ivyGlimpse, and the source code can be seen here. We won't review that. It has two main pieces. The first is the UI component, which lays out the interface. So somewhere here we're defining UI equals fluid page with a whole bunch of layout commands. And then there's a server function which goes and constructs the various plots based on data in this summarized experiment. And so if you run the ivyGlimpse function from the command line, it has a little problem in RStudio because of the sizing of the interactive graphs, but from the command line you now have the ability to change the quantities that are being plotted, and then to do stratification of the data based on image features. A new feature in this version of the app, it's not in shinyapps.io, is that if you click on one of the points, it will take you to the actual image data. So Once we've got all of that together, we have a package that can be installed from GitHub. It's relatively easy to use RStudio to deploy the app to shinyapps.io, and that's what's been done to give us the shinyapps.io version of ivyGlimpse that has been reviewed in the other video. So I hope that is a helpful review of the underlying materials, and that we can expand the app to give us access to things like this, where we can plot the distribution of expression of a selected gene across subtypes of tumors and relate at a higher level of resolution to image-related features.